We are going to discuss 11.3 next section, and that includes the velocity, acceleration and speed. Because we are discussing the curve, and when we discuss the motion along the curve, any particle is moving along the curve. When the particle is moving, there is a motion. When there is motion, we will get the velocity, we get the acceleration and we get the speed. Now we know that if the s is the distance covered in time, then we know that ds by dt over velocity, rate of change of distance is velocity, and rate of change of velocity is our acceleration. And then when we are going to take the speed, we take the magnitude of the velocity. The same definitions, basic definition for the velocity, acceleration, speed, we are going to use it here. But here our motion is along the curve, and the curve is given by the vector value function. And we have seen that we can find the first derivative and second derivative of the vector value function. So apply this one to find the velocity, acceleration, time. So we say we having here the curve is given by the vector value function r of t, and our r of t is f of t I plus g of t j and plus h of t k. So when I want to find velocity, so my velocity is r dash of t, and that is our dr by dt, and we can just rewrite dr by dt by taking the derivative of the function. We get here f dash of t plus f dash of t I plus g dash of t j plus h dash of t k, the first derivative. We want to find acceleration. So acceleration, as I told, we can have r double dash of t, that we can see this is my v of t. I can write here this is my v of t, the velocity. So it's equivalent to dv by dt. I will say this is equivalent to dr dash by dt. So when we take the second derivative of this one, we get here f double dash of t, the second derivative I, plus g double dash of t j plus h double dash of t k. So that gives me the acceleration. I want to find the speed. So as we mentioned, with the speed is magnitude of the velocity. Speed is magnitude of velocity. When you say speed, this is equivalent to the magnitude of v of t, magnitude of velocity. So what's the magnitude of velocity? We take root of this one. We get here f dash of t whole square plus g dash of t whole square and plus h dash of t whole square. That give me the speed. So this here number 1 velocity, number 2 is acceleration, number 3 is speed, and I will explain you further by giving you the example for this one. I give you the example. In this example, we want to find the velocity, speed and acceleration of particle that moves along the curve C given by r of t, that is equal to ti plus t cube j plus 2t square k at the time t equal to 1. So we want to find the velocity, acceleration and speed. So if we want to find the velocity, our velocity, we are having just developed the formula for this one. Our velocity v of t is equal to dr by dt. So we take the derivative of this one. Derivative of this one is equal to I plus 3t square j plus 4tk. Then I can find my acceleration. So my acceleration is our a of t, and my a of t is equal to, I just make it more clear, acceleration we denote it by a of t. A of t is equal to dv by dt. We take derivative of r d to r by dt square, same thing we can say. So we get here 0I plus 6tj, we take derivative of each of the component, 4k. So this is my acceleration. Now I want to find the acceleration and the speed when t is equal to 1. When t equal to 1, v1 is equal to I plus 3j plus 4k is a vector, and the acceleration a of 1 is equal to 6j plus 4k. Now I want to find the speed. Now my speed is magnitude of the velocity. My speed is equal to v of t, magnitude of this one, and we can write this equal to I square plus 3t square. This is not 1 square, not I. This is here is the component of this one. This is equal to 1, the velocity vector f of t, and then here is plus 4t whole square. Now we have here this is equal to root of 1 plus 9t square, take square of this one, 9 to the power 4 plus 16t square. When I take here t equal to 1, I will get here this result is equal to root of 1 plus 9 plus 16, and we get here root of 26. So this is my speed, and we are having this as scalar quantity. Speed, velocity is the vector quantity, and acceleration is the vector quantity. In next example, we are going to find the component of the velocity and acceleration along a given vector. So we are given the curve, the particle moving along the curve. We are given the parametric equation x equal to t square, y equal to t minus 4, and z equal to t cube minus 3. And the vector which is along which we want to find the component of velocity and acceleration, that's at time t equal to 1 along vector b is 2i minus 3j plus k. We have already done the component of the vector along vector. For example, given vector a is equal to a1i plus a2j plus a3k. A vector b is equal to b1i plus b2j plus b3k. We have to find the component of vector a along b. So we have the formula a dot b over magnitude of b. We have already done this one in a scalar product. We use this one to find this one. So here we write first the vectorial function r of t. Vectorial function r of t is t square, we have t minus 4, we have t cube minus 3, and I find here the velocity. My velocity vector is given by, this is the v of t, and our v of t we can find v of t by taking the derivative of r of t. So we say this is equal to dr by dt. We take the derivative of each component, we get here 2t plus 1 and 3t square. Here is 2t, and then we are having here the second component is 1 because t square, derivative of t is 1 and derivative of 4 is 0. T cube with 3t square. This is my component of velocity at any time t. So I can find here my acceleration. My acceleration is, we take the derivative of this one, a of t is equal to dy by dt, r as I mentioned, we are having d2r by dt square. So we take the derivative of this, the velocity vector. Derivative of 2t is 2, derivative of 1 is 0, and derivative of 3t square, that is equal to 6t square, 6t, not t square. We are having here this as here is just 3t square, and then we take the derivative, and the derivative will be equal to 6t. So here we are having 6t only. Now we find the value of this one at t equal to 1, because we want to find the component of the velocity vector at t equal to 1 and acceleration along the vector b. So this is equal to t1, we get here 2, we get here 1, we get here 3, and our acceleration vector at t equal to 1, that's equal to 2, 0 and 6. Now we are having here the vector b given to us. Our vector b is 2i minus 3j plus k. We need the magnitude of vector b. Magnitude of vector b is equal to 4 square of component b1, b2 is minus 3 square will be 9, and then that 1 is 1, so that give me here root of 14. Now I can write here number 1 component of vector v1 along the given vector b. So I can write this equal to component of v1 along vector b is equal to v1 dot product with b or magnitude of b. So I take the dot product, I have given two vectors, we get a 4, we get minus 3, we get here plus 3 over the under root of 14. So this gives me 4 over 14 under the root. That's my component of v1. along. Then we want to find component of vector, the acceleration vector a of 1 along vector b. So I can write this as component of a1 along vector b, that will be a1 dot b over magnitude of b. So I can find here a1 dot b dot product two vectors, this is equal to a1 b1. We get here 4, then we have here plus 0 and plus 6 over magnitude of b is equal to 14. We add this one, we get here the answer as 10 over root of 14. So these are my components for the velocity and acceleration along vector.